About our linear pair or our angle pair relationship, we learned the corresponding angles postulate, the alternate interior angles theorem, the alternate exterior angles theorem, and the consecutive interior angles theorem. So those postulates and theorem told us that corresponding angles are always what? Congruent. Alternate interior angles are always congruent. Alternate exterior angles are always congruent. And consecutive interior angles are supplementary when our transversal crosses two parallel lines. Okay? So that's what those theorems all told us yesterday. Except for corresponding is a postulate, not a theorem, because it hasn't been proven. Cannot be proven. So we have a corresponding angles converse theorem. Now, haven't we talked about a converse before? Y'all remember from chapter 2 what a converse was? It's when we have our if-then statement and we swap the hypothesis and the conclusion. Y'all remember that? We write it in the other order. It's called the converse. So, the corresponding angles postulate said, if two parallel lines are cut by a transversal, then corresponding angles are congruent. That's what we learned yesterday. The converse theorem says if two lines, just lines, are congruent, are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So the original postulate told us they were parallel, and that showed that corresponding angles are congruent. The converse theorem said if corresponding angles are congruent, then the lines are parallel. So do you see how they're doing that? So yesterday the theorem told us that the lines were parallel, which showed those angles are congruent. The converse theorem tells us those angles are congruent, and that proves that lines are parallel. All right? So something that you might need to know, I have it on my symbols over there. If you see two slanted lines, that means parallel. So A, two slanted lines B, means line A is parallel to line B. So what symbol meant perpendicular? Upside down capital T. All right? Two slanted lines means parallel. That's the symbol for parallel. We're going to see that symbol a lot today. So, here's a problem that we actually have to work out using this converse theorem. Hopefully, y'all go ahead and highlight that converse theorem on your handout. Sorry, I meant to tell you to do that. It's postulate 16 right there on the front page. The corresponding angles converse postulate. So highlight that one on your page. Okay? So if corresponding angles are congruent, then your lines are parallel. So it says find the value of x that makes line M parallel to line M. That's what these symbols mean. Line M parallel to line N. So what would make this and this make these lines parallel? Well, what's the relationship between these two things they gave us, these two angles? They're corresponding, right? Well, the corresponding angles converse postulate says if these corresponding angles are congruent, then the lines are parallel. So, to find the value of x that makes that true, how do you think I would do that? Set them equal to each other and then solve for x. Yeah. So if I want to find the value of x that makes these two lines parallel, I'm going to set these two corresponding angles equal to each other. All right? So I'm going to say 3x plus 5 equals what? 65. And then I'm going to subtract 5 on each side and get 3x equals 60, and then divide by 3, and x equals 20. Now let's check it. 3 times 20 is plus 5. Does that equal 65? It does. Okay, so those corresponding angles are equal to each other. Therefore, M is parallel to N. Okay? So that's how you do that. Easy as pie. All right. Then we have the alternate interior angles converse theorem. Find this on your handout. And I believe it's on the back. First one on the back. First one on the back. Highlight that one, please. The alternate interior angles converse theorem is the converse of the alternate interior angles theorem. Okay, first one on the back. So converse theorem, remember, reverses the order. So it says if two lines are cut by a transversal so that the alternate interior angles are congruent, then the lines are parallel. So converse angle pair relationship theorems are telling me that the lines are parallel. So I'm going to be using these later to prove lines are parallel. Okay, so we're all building up to parallel proofs. Sure, just quit interrupting my class. You get another one? Good. All right, so top one on the back. If alternate interior angles are congruent, then the lines are parallel. Go on to the next one. We got a converse theorem for exterior as well. So if alternate exterior angles are congruent, then the lines are parallel. Okay? All right, so the next one is consecutive interior angles. Are consecutive interior angles congruent? No, what are consecutive interior angles? Supplementary. So if two lines are cut by a transversal so that consecutive interior angles are supplementary, then the lines are parallel. So you should have corresponding angles about a third of the way down on the front, and then the converse theorem for alternate interior, alternate exterior, and consecutive interior on the back. Okay? So those are four converse theorems. We learned the original postulates and theorems yesterday. Today we're doing the converse. So yesterday they told us they were parallel. Then the angles are congruent or supplementary. Now they're telling us the angles are supplementary or congruent, which proves the lines are parallel. Okay? So, proof. So excited. So excited. Parallel proofs are my favorites. I'm going to let y'all copy down what it says and the picture. The picture is important. Now, y'all are going to be doing these on your own in a little bit. Well, with your group. I meant without me. If you'd been on class on time, you'd know this. That's one hit before. So just in case you're curious, we're going to do 3 proofs in class, and then you guys are going to do 4 in your groups. Okay, we're going to do 3 all together, and y'all are going to break up into groups, and y'all are going to do 4 with your groups. Now we're going to use our theorems that we have highlighted on this handout, so we might want to keep this handy. We're also going to use properties and theorems that we learned in Chapter 2. Somebody tell me a property or a theorem we learned in Chapter 2. Say it. The transitive property. Y'all remember what the transitive property basically said? You need 3 things, right? Basically, it says if two things are congruent to the same things, then the other two things are congruent to each other. Right? It's line S. Alright? So transitive property said if two things are congruent to the same thing, then they're congruent to each other. It takes three things. We also learned symmetric property. You can reverse the order. We learned reflexive property that equals each other or equals itself. We learned substitution property, right? If two things are equal, we can replace one with the other. We learned the angle addition postulate, which says little angle plus little angle is big angle. We learned segment addition postulate means little segment plus little segment equals big segment. We learned a lot of things. Y'all are smart cookies, right? Well, we did. We did. How do you remember it? You practice it. Yeah. I mean, I know a lot of things. Like I used to could say a lot of history stuff, but history is not my favorite thing. So I have not freshened myself on history in a very long time. Probably in the last 15 years since college. No. Yeah, let's learn about Euclid. He discovered all this stuff.
Oh, is that who had the time to sit down and wait?
Yeah, it's Euclid. All right. So that's why this is called Euclidean geometry, just in case you're wondering. This is called Euclidean geometry. Unless you're working in the fourth dimension, then it's non-Euclidean geometry. Yeah.
Where's the fourth dimension at?
Not here, because we're in 3D. All right. So, okay, read. What does this mean? Line R is parallel to line S. And they also showed this in the picture with their little extra arrows. Y'all see that? So we also know that there. And angle 1 is congruent to angle 3. All right? They marked that on the picture as well. Because remember we said congruent angles have the same number of little arcs in them? Everybody's been looking up here. If you see little arcs that match each other, that have the same number of little hooks in them, okay, they each have one hook. That means that they are congruent to each other. So remember, line segments have like the little tick marks. Angles have the little arc measure thing. Okay? So we know those. So we're going to prove that. Now, anytime it says prove, that means it needs a statements and reasons table. So here we go. Statements and reasons. This is a proof, dear. I don't know. They're important. All right. What is something they gave me? What did they tell me? And what else did they give me? They gave me two things, didn't they? They gave me R is parallel to S, and angle 1 is congruent to angle 3. And those are both given. Now, sometimes they split that into two different givens, okay? I like to put my givens all together. But sometimes you could split those into two different givens. Okay. So, I don't know that P and Q, see I've got 4 lines here, right? P and Q look parallel, but I cannot say they're parallel yet. That's what I'm trying to prove. Okay? So that will be my very last statement, that is P is parallel to Q. So I cannot assume those are parallel in anything. All right? But I do know these two lines are parallel. All right? Now, these two lines are parallel. Ignore line P for a second. So if I could cover that up, I would. So I got these two lines. Let Q be a transversal. Do angle 1 and angle 2 have a relationship? What are they? They're in the same position, aren't they? Because we already know these two lines are parallel because they're marked and they told me that. And Q is cutting through them, so it's a transversal. So these two are in the same spot, right? So these are corresponding. So I can say, and we learned yesterday that corresponding angles are congruent. So I can say angle 1 is congruent to angle 2. And that's because of the corresponding angles postulate. If if I do this, y'all, angle with an S, do y'all know that means angles? If I do an angle sign with a little S, or if you can put apostrophe if you want to, technically you're not supposed to because it's plural, not possessive. Grammar lesson. But do y'all know that means angles? Okay, so now I'm gonna tell you that if I ever do that, it means angles. All right, corresponding angles postulate. Y'all with me? So look at what I've got here. Angle 1 is congruent to angle 3. Angle 1 is also congruent to angle 2. So what else can I say? Yes. If angle 1 is congruent to angle 3, and angle 1 is also congruent to angle 2, then 3 and 2 must be congruent to each other. Y'all with me? What property, postulate, theorem, whatever says I can say that? Yeah. What is this? Two things are congruent to the same thing, then they're congruent to each other. Very good. Yeah, why'd I put it congruent to itself? It's not reflexive, it's transitive. Sorry. Y'all with me? You with me? Okay. Now look at 2 and 3. What's their relationship? Yeah. We said they're congruent to each other, right? So since they're congruent to each other, well, these two lines are cut by transversal R, right? Well, we just learned a converse theorem that says if alternate interior angles are congruent, then the two lines are parallel, right? Aren't we trying to prove two lines are parallel? Which lines are we trying to prove is parallel? Is that the ones I just proved? Yeah, so I can say P is parallel to Q because of the alternate interior angles converse theorem. THM is theorem, okay? Alternate interior angles converse theorem. Congratulations, you just did your first parallel proof. Y'all see that? Converse theorem says if they are congruent, then the lines are parallel. And that's what I was trying to do is prove parallel. So if you say the lines are parallel, you have to use a converse theorem to say that. Okay? You have to use a converse. So if I leave out the word converse, this is wrong. Okay? So to say lines are parallel, you have to use a converse theorem. Okay? And we know it's alternate interior because we said 2 and 3 are congruent to each other. So I know 2 and 3's relationship. Well, they're on opposite sides of that transversely in between those two lines. So that's alternate interior. Y'all with me? So you've got to know your relationships, and you got to know that a converse theorem proves parallel. We good? Let's do another one. So much fun. These are my favorite. I like these better than triangles for some reason. These are proofs. Anytime you have a table with statements and reasons, it's called proof. Anytime it says prove, I got to see statements and reasons. So y'all go ahead and write this one and draw the picture, please. I don't know the worksheet. So when you draw the picture, put the little numbers in. That's a 3. It looks crazy, but it's a 3. I'll fix it. That still don't look good. 3. All right, when you get that drawn, go ahead and do your statements and reasons because it said prove. So I got to have a statements and reasons table. Move my arrow, please. All right, somebody tell me a given. A is parallel to B. And what else? Angle 1 is congruent to angle 3. So those are given, okay? Y'all see that? And again, if you want to list those as separate givens and have two givens, you can. All right? The book does that a lot. So it's already marked in the picture. So if it's not, after that, if they tell it to you in writing, make sure it's marked in the picture. So it is marked that these two lines are parallel because that's what those little arrows mean. And angle 1 is congruent to angle 3, and those are marked as well. So if they don't mark your given on the picture, then you mark the given. Okay? So let's look at this. 1 and 3 are congruent. All right. So all I know right now is that these two lines are congruent. Or these two lines are parallel. Right? So these two are parallel. So ignore line D for a second and look at line C. The angle 1 and angle 2 have a relationship. What is that relationship? They're not corresponding. They're alternate x's. These are my parallel lines. C is my transversal. Right? Okay. So they are on the outsides of those parallel lines and in opposite positions. So those are alternate exterior angles. And what do I know about alternate exterior angles? They're congruent. So I can say angle 1 is congruent to angle 2. And that's because of the alternate exterior angle theorem. Okay? Now look at your statements. You can do something with your statements. What can you say with your statements? Yes, I can say that angle 2 is congruent to angle 3. How can I say that? Right. Angle 3 is congruent to angle 1, and angle 2 is congruent to angle 1, so they can be congruent to each other. What property says I can say that? Transitive. Because I got 3 different angles. If 2 of them are congruent to the same thing, then they're congruent to each other. That's the transitive property. Now I know 2 and 3 are congruent to each other. Well, look at 2 and 3. What's their relationship? They're alternate interior angles again between C and D, aren't they? Right? So I can say what about C and D? They're parallel. And that's what I'm trying to prove, isn't it? Now, why can I say that? Alternate interior angles, converse theorem. You have to use a converse theorem to prove parallel. Alternate interior angles, converse. Now, you can't just say alternate angles. Now, I did abbreviate, but you can't just say alternate angles because it could be alternate interior, alternate exterior, okay? So at least give me a few letters. Let me know which one it is. Okay? Like I said, I'm okay with abbreviating. Just don't I'm stuttering. Woo. Just don't make your abbreviations cut out important words. All right? Because there's 2 different kinds of alternate angles. There's alternate interior and alternate exterior. Any questions? All right. Fill in the blanks. Now, I'm not turning y'all loose on a complete proof just yet. And on your test next week, it is not, you're not going to have to do all the statements and all the reasons by yourself. All right? You're going to have 2 tests next week back to back because we have to have a Chapter 3 test and we have to have a benchmark exam. Per Dr. Pyron. I can't help it. So it's either going to be Tuesday and Wednesday or Wednesday and Thursday. Per Dr. Pyron. I can do it whatever day I want to. It's not your choice. It's mine. That makes me want to do opposite of what you said. Well, this recording is going to let me go show that to the principal and your mama if you want me to. You being disrespectful.
I thought you were trying to go for a bribery.
No. Just depends on where we are. All right, everybody try these. You got 3 blanks. 3 blanks. Try to fill them in for me, okay? Three blanks. Ooh. First one's interesting. I said the first one's interesting. Didn't say freshman. You need to be writing. Now, if you can't get this one, you still can get this one. And if you can't get this one, then you can get this one, then you can get this one. All right? So even if you can't get the first one, you still should be able to get the other 2. Now, y'all, trying and missing these is okay. We're not going to do proofs perfectly right now. This is the first day y'all have seen parallel proofs. But there is no excuse to not try. We're all doing these in pencil. They have erasers for a reason. All right, first of all, what did they give me? Did they mark it on the picture? No, so they didn't mark it, so you should mark it. 4 is congruent to 5. Right? All right. The first statement tells me that angle 1 up there is congruent to angle 4. They tell me that, so I can mark that with the same number of tick marks because all those are congruent, right? Now, what's 1 and 4's relationship? Vertical angles. So, yeah, that's a theorem from way back in chapter 2. Y'all with me? Those are vertical angles. Angles across from each other are vertical angles. All right. Now I don't even need this part to do this. If angle 4 is congruent to angle 5 and angle 1 is congruent to angle 4, then what can I say? And my clue was it's transitive property, right? They told me I was using transitive. So I can say which two are congruent? 1 and 5, right? If they're both congruent to angle 4, then they're congruent to each other. So angle 1 is congruent to angle 5. Raise your hand if you got, now you could have swapped the order, but raise your hand if you got that in that blank. Okay, so what is 1 and 5's relationship to each other? They're corresponding, right? And I'm proving that those lines are parallel. So what do I need to use? Corresponding angles converse. And that one is actually a postulate. If you put theorem there, I'm not going to dock you. All right, so raise your hand if you got corresponding converse. Okay, you've got to know your relationships. All right, you've got to know those relationships. All right, so that's the end of the lesson. We're going to do group work now. Bye-bye.